Okay, so let's prove the first one. We only have the definition, so we need to get from here, we need to get this. So let's do it. So we have that the variance of xi is equal to the expected value of xi minus the expected value of xi squared. Okay, so next we can do what? So we have this square, so let's just open this square somehow. So we have the expected value of xi squared minus 2 times xi by the expected value of xi plus the expected value of xi squared. And then what can we do now? Linearity, right? So we can, by linearity, we can apply this expected value to all the summands. So we'll have expected value of xi squared minus the expected value of 2 times xi expected value of xi plus the expected value of the expected value of xi and this square. So this is done. This part is just the expected value of xi squared. Now, what is this equal to? So we can put out what? These two right here and the expected value. We need to keep just xi. So we'll have 2 times the expected value of xi multiplied by the expected value of xi. Right? Plus, what is this equal to? The expected value of xi squared, right? Because this is a constant. So this is expected value of xi, the whole thing is squared. So we have the expected value of xi squared, the expected value of xi, and here we have minus 2, then we have minus 1, right? So we'll have expected value of xi squared minus expected value of xi squared, like this. That's it. We prove it. Very simple. Okay? Any questions? No questions. Okay. Now, well, the variance is always non-negative. That's clear. That should be clear because we have a square here. So that's it. Now, the only case when this is 0 is when this is equal to this. And the expected value of xi is equal to this. Always when we're talking about when xi is a constant, the number exactly. So that's it. So there's no need to prove that. It's given. Now let's just use property number. Let's prove property number 3. So we need to find variance of xi plus b. So let's use which one? I don't know, the definition or... Yeah, sure, let's use the definition. So this is equal to the expected value of... So instead of xi, instead of this xi from here, I need to write xi plus b. So we'll have xi plus b minus the expected value of xi plus b, and this is squared. Okay, now, what to do with this? So what do I need? I need the variance of psi somehow. Okay, so this is equal to the following. This is the expected value of xi plus b. So let me write just like this, xi plus b. Okay, now let me write like this, xi minus the expected value of xi plus b minus b squared. So we can see that here we can cancel this b. We can cancel b, right? So, and here, this a, we can write it outside. So, and we have this common a. So this will be equal to the expected value of a multiplied by xi minus expected value of xi, and the whole thing is squared. right? So this will be the expected value of a squared and psi minus the expected value of psi squared. So this is equal to a squared and the expected value of psi minus the expected value of psi squared. And this is just the variance. So this is a squared by the variance of psi. So we prove it.